Okay, so let's go through some worked examples here to follow up on that first video. So the instructions are find the first four terms of this this sequence here, given as a general term, or the nth term. So here we go. A sub 1, the first term, is going to be 4 times 1 minus 1. So we're putting 1 in for n, and I believe that'll be 3. And second term, a sub 2, be 4 times 2 minus 1. Let's see, that's 8 minus 1, that'd be 7. And a sub 3, 4 times 3 minus 1, 12 minus 1, and see, that would be 11. And let's see, the fourth term we're going to find, a sub 4, be 4 times 4 minus 1, that is 16 minus 1, or 15. And then writing the sequence that we've been asked for as a nice list here, we would have 3 comma 7 comma 11 comma 15. All right, let's try a different example. I'm trying to get a variety of looks to these situations that will be useful to you. Okay, find the first four terms of a sub n equals n squared plus 1. So we're off here. The first term, a sub 1, is 1 squared plus 1. That would be 2. A sub 2 is 2 squared plus 1, which means 4 plus 1, or 5. A sub 3 equals, let's see here, we got 3 squared plus 1, otherwise known as 9 plus 1. That's 10. And then finally, the fourth term, a sub 4, that would be 4 squared plus 1, which is 16 plus 1, or 17. And writing this as a nice little list in horizontal form. Let's see, now we'd have the first term is 2, second term is 5, third term is 10, and fourth term 17. All right. Let's look at a different look here. I'm just trying to get you used to seeing the n's in various places. The n's in various places. So here, I'm trying to get that arranged there. All right. So find the first four terms of a sub n equals n divided by n plus 1. So a sub 1 is 1 divided by 1 plus 1. That's 1/2. A sub 2 equals 1 divided by 2 plus 1. That's 1/3. A sub 3 is equal to 1 over... that's actually a mistake, isn't it? Because I'm not adjusting my my numerator correctly. So scratch that. Sorry about that. We'll put it in the right formulation in red. All right, let's try this again. A sub 1, let's be careful. 1 in place of n. All right, fine. The first term is 1/2. That's all right. Now a sub 2, 2, because n is 2, and it's right there in the numerator. Hello. And then 2 plus 1, let's see, that would give us 2/3. Very good. A sub 3, the third term, 3 in place of n, 3 in place of n, so 3/4 is the output. Very good. Then a sub 4, 4 over 4 plus 1, 4/5. All right. Okay, I'll try to be more careful there about replacing n with the appropriate number, the term number, really. Let's do one more example here. I'll try not to mess that up. Okay. First four terms. All right. First four terms of a sub n equals 2 to the nth power divided by n. All right. A sub 1, 2 to the first power over 1. That should simplify to 2. A sub 2 would equal 2 squared over 2. All right, that would be 4 over 2, otherwise known as 2. Very good. A sub 3 equals 2, let's see, to the third power over 3, and I believe that would be 8/3. And finally, a sub 4, the fourth term in the sequence, 2 to the fourth power divided by 4, Let's see, now 2 to the 4th is 16. 16 over 4 is 4. Now, writing the sequence in order, which I didn't do in that last problem, in the sense of in nice left to right. We have 2, 2, 8, 8 thirds, and 4. And yes, it occurs here, right, that we have a repetition in the sense that the first term and the second term end up being the same number. There's no problem with that. There's no necessity in these sequences that the terms that are next door to one another be different. There's no need for that at all. So here we are. We dealt with that one. So I hope these worked examples helped a little bit to kind of make this a little more concrete. And I think the next video will get into alternating series. All right. Thanks much.